resource persons for this 6 days FDP. I hope uh, you'll gain so much of information through this 6 days of FDP. And I wish and I hope all the participants to not to miss any of the sessions. Uh, so thank you for participating, and once again welcoming everyone. Thank you.
Thank you, sir. Now I welcome our beloved principal, Dr. S.V. Subramanian, sir, to deliver the inaugural address.
Thank you, Mr. Manath. First of all, I'm happy to be associated with this inaugural session of 6-day FDP organized by Department of Mechanical Engineering. I congratulate all the faculty members of the department, the head of the department, Mr. Sridath, other coordinators, and also the resource persons and the participants. I'm extremely happy that Sripati is organizing, every department in Sripati is organizing faculty development program during this vacation time. Already 4 departments have completed their FDPs, and now today we are starting the FDP in mechanical department, and also I think in triple department also it is happening today. So this is a wonderful experience and a good opportunity for both the faculty members from the Sripati as well as from other organizations to enhance their knowledge in the field of engineering education. As teachers, we have to update ourselves, which is a necessity, especially in the field of information communication technology, and every aspect of engineering education is making changes. The conventional teaching learning process is making lots of changes. It is becoming more learning oriented, more student oriented. So the pedagogy involved in teaching are to be changed. The teachers will have to become more than or even a facilitator than a conventional teacher. So attending the faculty development programs will definitely help the teachers to improve their technical knowledge in the latest trends in engineering education. And also this gives a opportunity for networking among various faculty members, resource persons, and so on, so that they can continue their activities, learning activities forever. So this should not stop here. The learning activity, as far as the teachers are concerned, should continue. You have a host of resource persons. Dr. Neelesh, who was a former staff member in this college, he is there already in the screen. I am able to see his face.
Yes,
Thank you, Mr. Neelesh.
Good morning, sir. Yeah, welcome, sir.
I'm happy that you are organizing the or you are conducting the first session here.
Yes,
So
sir.
personal welcome from my side.
Thank you, sir. Thank you.
Please share your knowledge
Sure,
and
sir.
continue the whatever information you are
Collaboration, sir.
sharing with the staff members.
Yeah.
Please continue and
Sure, sir.
later convert this FDP into an area or a section where you can develop the technical knowledge, conduct some research-oriented activities, publish papers, apply for
Okay, sir.
patents, and see, these are all certain minimum responsibilities a teacher will have to continue as a teacher, because we are not in a tutorial college. We are running
Yes,
an
sir.
engineering college
Exactly.
where the apart from the conventional teaching learning, a lot of other activities like research activities, patent registration, and then students startups and things like that. So many activities are to be carried out in an engineering college.
Okay.
So I hope this will give a chance for the Department of Mechanical Engineering of Sripadi to develop something and then later carry it on. Once again, I congratulate the Department of Mechanical Engineering and all faculty members for organizing this FDP. Thank you very much. I formally announce that this FDP is inaugurated. Thank you very much.
Thank you. Welcome, sir.
Thank you, sir. Now we are proceeding to our first session. Regarding our resource person in the first session, Dr. Neelesh Ashok has completed his PG and PhD in material science from Amrita campus Coimbatore, and he has also authored a textbook in this incorporation of AI and material science. I'm sure his vast knowledge will be useful for every one of you. So I welcome Dr. Neelesh Ashok for the session.
Thank
you,
you. Yes. I think you can formally start the session without wasting much time. Can you hear? Is it audible? Is it audible?
Yes, sir. Yes.
Yeah. I think we can start, right? We can proceed with the session, right?
Yes, sir.
Inauguration is over, right? Okay. So first of all, a very fine morning to all of you. I have a humble request that this session today and tomorrow I'm handling, as people told, is related to AI for materials informatics. It is an interdisciplinary area where computational or something called as AI techniques, which is booming in, which is flourishing now, and which is, apart from that, which is very much requisite for our sustainability, our sustenance, okay, our growth and development. So these are the areas which I'm going to cover. Before that, I have a humble request, like all of them should switch on the cameras. I should see the people. If you are not in a position, please make some arrangement and I should see all the people on screen. And this should be like it is not like a PPT and deliver. It should be like an interactive session. I'll be demonstrating some hands-on, okay, using Google Colab, using Python. All these will be in a blended form. It's a mixture of support during these two sessions, right? So before moving to the general idea I have to deliver, what do you mean by AI for materials economy? So that I'll just showcase the book which was recently published. I think the sound is clear, right, Manat?
Yes, the voice is clear.
Okay. So in this we can see actually we have published this. Why I'm starting from this is like you should know like how this can be applied to the mechanical domain, right? Mechanical domain, material science, additive manufacturing, okay, polymer science, polymer nanocomposites, dielectric materials, okay, different types of areas of carbon-based nanomaterials. So how these techniques can be, so it's something called as studies in the computational intelligence. This is the series which has been published by Springer, where we have published this book. Okay. So why I'm starting with this is actually we can see there are different aspects of materials informatics, or otherwise known as AI for material science. So basically, so I'm starting with some topological indices for vector representations of the graph. So I start from the very humble beginning. What do you mean by vector? A scalar or a vector. So that is a very basic maths. Some concept of linear algebra, optimization theory, statistics has to be there behind the working principle of AI. See, you take a machine learning model, say so you might have heard some ABCD about AI, right? Nothing but a machine learning model is that we are trying to feed the data to the machine and machine understands it, it represents in a different way, and we are finding out how this data can be taken either for a classification or for a prediction. This is the basic nutshell point of view, how a machine learning can be applied for a system, right? So generally, as a mechanical engineer, we have only two things in our hand. One is our experimental data. Say, for example, the stress strain curve, which we teach for our mechanical engineering students in, I think, S3 or S2, the very fundamental strength of materials. That stress strain characteristics is something called as a data, right? We have Excel points of stress and strain at each points, the variation of the stress with respect to strain, right? So this data can be mapped to another system where we can produce a new type of stress strain characteristics at different conditions, which a machine learning is doing, right? So that is a primary, just one of the basic simple example, as we all know about like how we can talk about this application of the AI for the material. So we can see the different chapters it has been published here. Say, for example, topological indices, starting from the very basics of vector representations, toxicity prediction using convolution neural networks. This neural networks, CNN, okay, ANN, etc., has been carried out or has been developed in the form of a deep learning approach. And the people have a normal judgment that only computer science people is specialized for. But there is a small deviation between the, see, of course, the architecture is based upon the computer science perspective. You have hidden layers and something like a deep learning approach, or some architecture of neural networks is there for CNN or AMN. But the application of CNN for this toxicity prediction, okay, say toxicity prediction is one of the application where we will be distinguishing two classes of materials, whether it is a toxic or non-toxic. This was the second chapter. So step by step, of course, we don't have the time within 2 hours to go through the entire sketch of the book, but at least some idea about the chapters we'll give. I am giving you so that it will feed some seeds for you to grow and for you to develop which all perspective. Then we'll see some practical examples using the Python, right? Using the Google Colab, right? Where you can see some coding examples where you can do some hands-on. So please be ready with your laptops. I don't know how far many of them have switched on the camera. That is fine. But please be ready with your laptops so that at least by the next by 10:45, 11, next last hour of the session, we can work on some coding examples, right? So in that, there is something called as Google Colab. Meanwhile, while I am talking itself, you can get engaged to that. Google Colab, just log into that. Google Colab, you can see. Then you can just using your Gmail ID itself, you can get a screen, right? So there, that you have to log in. The procedure only takes only 2 to 3 minutes. You can just do that side by side. Google Colab, right? So this is the third chapter that is based upon the AML and the polymer science. So enhancing the materials informatics through predictive modeling. Okay. See, something called as modeling is being carried out. So I don't know how far your experience with some modeling aspects. Say, for example, design of experiments is there, response surface methodology is there, some statistical modeling is there, or we'll come down to little lower level. In the linear algebra, you have seen numerical methods are there. Okay, these are all some of the models where, see, so for example, simple sine curve or a cosine curve, which you have learned, right? Sine curve and cosine curve is basically a graph. It's actually a model where you are fitting the data, and based upon the angle and the variation, you are getting a curve, right? A curve can be taken as a model fitting, or we can say what is the difference between the actual value and the predicted value. Okay, the square of the distance or something called as R square is there. Okay, RSM is there, root mean square, error, R square. So these are all the error or the accuracy parameters which is used or which is requisite for the machine learning models, right? So some of the machine learning models we can discuss the basic of support vector machines, right? Support vector machines is basically just a classification of the two, whether it is there, yes or no. Like for example, toxicity prediction, whether it's there or not. So what you can do as an, like I am giving away the topics. Why? Because it should not be like a delivering of an entire PPT, making some PPT of 100 slides and just delivering that. You should try to have, as sir told, have a collaboration of your data with this machine learning model. So should be the outcome of the talk which we are going to deliver, right? Apart from that, I can just show the book and I can finish up 2 hours. But how your data can be infused to a machine learning model and how it can be generated how you can incorporate in a technique into your aspect, right? This is your, this should be your outcome of, you should be thinking in that direction while I am talking, right? So the thinking of that thought form of that data to development of an AI model or incorporation of AI model should be the outcome of this talk, right? So then the the third one again is coming to the physics-informed neural network. This is one of the most important aspects now. It's known as physics-based neural networks or physics-based machine learning. Okay, physics-based neural networks is basically you are taking the boundary condition, as you all know. Some of them might have learned about, I don't know, people are there from civil background or mechanical background. Anyways, there is something called as finite element methods where you use boundary condition, okay, where we use some forces. Say, for example, you will be doing CFD is there, computational fluid mechanics is there, computational solid mechanics is there. All these, there is something called as finite element methods, where they will be using some finite difference method as well as finite element volume method or finite element method to incorporate, say, some boundary conditions, and you will be finding some output, like for example, stress strain, like F is equal to KD, like force you'll be finding from the displacement, there is a relation between force and displacement, something called it in a basic nutshell. People are there from diverse backgrounds, so I'm not moving deep into it. But there is some physics which is connected, which is based upon the given data or given boundary conditions, okay, given forces. And you'll be finding out the displacement. So physics informed neural networks, fundamentals and applications of phase-based model. Phase-based models is basically there are different types of phases. This can be diversified to electrical applications also. There are different phases. Say, for example, I don't know much about the particular application. Say dielectric application, dielectric constant, dielectric loss. Okay, using the Nyquist criteria, you'll be having the control system. You'll be finding out the different phases, right? So that phase-based models can be incorporated with the physics-based neural network. So electrical people can think about how pins, or otherwise known as physics-based neural networks, can be applied to that particular domain where your phase changes, right? Say, for example, the continuous voltage phase or continuous capacitance phase, induction phase. I don't know exactly what is the varying phase. So based upon that electrical parameters or electrical inputs, you can incorporate or infuse the physics-based neural network for the application. So why I am just again and again making the loop is like the different applications of the various AI techniques, say starting from the neural network, starting from the basic machine learning, then going on to the deep learning, then going on to the different NLP techniques, natural language processing techniques, that where you use to find some sort of representation to represent the chemical structure of the molecule, which I'm going to explain in detail, which is my research trust area. Then you can see about the physics-based neural network. Then you can see about the predictive modeling, where material science can be, material property can be modeled and developed. Okay. Then we see something called as the basics of the density function theory. Okay. Density function theory is one of the most dominant area where you can see the applications of AI have leveraged the density function theory applications to various energy materials, okay? Various types of energy materials, various type of carbon-based nanomaterials, okay? Then something called like explainable AI techniques. Explainable AI techniques is basically how the features, the different properties, say for example, in a mechanical engineering, we can see the different properties. Force will be there, stress will be there, strain will be there, thermal properties will be there, okay? Electrical properties will be there, optical properties will be there, magnetic properties will be there. All these can be taken as a features for a machine learning model. So how explainable AI, like for example, there are two techniques like sharp and line that gives a particular aspect of which feature contributes more, right? So that based upon that aspect, and the system itself is giving you how much percentage of the feature is contributing more for this application. Okay. So for example, in the image classification problem, I don't know how many might have heard about the TEM and SEM. Okay. So the various types of images, say for example, based upon the 10 micrographs or 10 micrographs, we can see the different types of phase boundaries, grain size, grain boundaries, okay, different types of nanofillers, different types of mesofillers, or different types of microfillers. So this type of different classification of the data, that is nothing but your medical image, okay, that can be done using the different types of feature selection process. So this type of feature selection, which is contributing more, that is given by explainable AI. This is one of the new area where this is being going on, right? Now we can see the sorry for interruption, just 2 seconds. Now, just yeah, coming on to the AI-driven robotic solution. So, see, this maybe the topic will be connected to material science or materials informatics in this era, but the fundamental aspect of material science is basically applicable or basically dominant in two aspects. One is in additive manufacturing, second one is robotics. I think there is one course, AI for robotics engineering or something, I don't know the title of that BTech engineering course that we also have here. We have something called as autonomous agents and robotic systems. These autonomous agents and robotic systems, like, is another application where your AI-driven system can be infused into. So mechanical people, even the electrical people, what is happening, or even the people from, say, I'm not focusing on these two, people who are working, say, for example, in electrical vehicle project. We have electrical vehicle project where we induce a robotic system to the electric vehicle, right? So there, the how the robot is being controlled by an AI mechanism. Say, for example, a robotic, I think we have a subject in S5 where we deal with the different types of motions like slider, crank, or I forgot the name, basically the different types of mechanisms where it is being used. Say, for example, gesture movement, like hand movement, we can see there is a project where the movement of the hand is being controlled by the sensors. Okay. So the sensor application, how the mobility of that particular hand or a particular wing of a robot, okay, or pick and place operations is being controlled by the sensors. So that movement, how far this can be moved, or how far, at what position it has to be changed. This can be an automated mechanism using an AI technique. So this is the another applications of AI-driven robotic solution. Now, another one, like we have, again, we are diversifying into environment, agriculture, okay, where how we can use the materials for healthcare, environment. So this was an application level chapter. I don't want to explain much about it because this is just an idea about how the different types of materials can be used for excuse me, healthcare applications, environment applications, and agriculture. So I'll just brief about healthcare applications. So the biomaterials, as we have already heard about, is biocompatible, bio-infused, biomimicable materials. How we use this artificial limbs, right? For example, e-skin, or otherwise known as electronic skin application. So people with amputated patients, they'll be having an electronic skin, right? So it will be like it's a biocompatible material where it will be having all the biological properties. So there will be an interaction between the human body and the biological property, right? So that the human body should not. Another important application, as we all know, that the head stent, which is put inside the human body, this is a type of biomaterial. So nowadays, the materials for healthcare, or otherwise known as healthcare informatics, what they are focusing is they are finding out the data based upon the sensor inside the human body, and then they are trying to do a regression model of what will be happening for a novel change in the material. So otherwise known as materials discovery, right? So this is a precision of precise output where I have seen we have seen about the various applications of the material science where we are doing. Now I am just deviating from the book. I'm just deviating from the book. And so initially, like people used to say the introduction first, then going for this. But in my case, I've done it in a different way. So I thought of telling you the outcomes of this workshop at the end of 2 days, or today and tomorrow, so that you can see some beneficial should be there after we attend this. So now let's give a basic introduction of myself, what I am doing, and how we can, as sir told, also it will be beneficial for your career development. Like how we can have a portal where we can collaborate, where we can intersect, where we can interact with the domains. Not only in the material science, the materials can be applicable for various applications, even for the sensor design, VLSI design, okay, even for dielectric properties, dielectric materials. So I'm connecting easy people and triple E people or instrumentation people here. Biomedical applications, so biological people or biomedical application people can come into picture. Also, apart from that, basic, we have the how and architecture of a deep learning can be modeled in a different way, or we can implement LLMs, okay, large language models. How we can implement LLMs, how we can learn, fine tune the data with the pre-trained models. All these are the portals where you can do it, right? So I started my journey in 2016. Now, just again, in 5 to 10 minutes, I'll be talking about myself. You should know who I am, what I am. So, before, I mean, this date is very important for me. 22nd June 2013, I have joined Sripati Institute of Management Technology immediately after my MTech program. Then I have moved on to PhD in 2016. I've started with the polymer nanocomposites, or otherwise known as high performance elastomers property model. So in this, we are focused on different types of polymers, how it can be modeled, how it can be nanocomposites can be generated. It was basically starting with an experimental procedure only. This was an experimental procedure. Then we used the different types of nano fillers like nanoclay, nanosilica, multi-wall carbon nanotubes, hybrid nanocomposites using carbon black for the various product applications. So this was basically something called as the polymers and the polymer nanocomposites. I hope I'm not debating because the polymers and polymer nanocomposites is slightly a different area where you might have heard about the polymers, like it will be and a combination of different types of monomers. The basic one, which different types of polymers, which is like additive polymerization or condensive polymerization. All these things we have learned in the +2 level or something like that. So in that, we have done different types of characterization like SEM, TEM, XRT, spectroscopic analysis, okay, dynamic and plastic, viscoelastic properties, okay. For this, the application was nothing but for the gamma radiation aging application, that is for product development for using the nuclear fields, okay. How it can withstand the different types of gamma radiations. Okay, gamma radiation, say for example, how we can withstand the different cumulative doses of gamma rays, in other words, I can say. So this in a one slide, I am telling you what happened for the about 4.5 to 5 years of my doctoral work. I published around 10 articles, Q1 and several conferences of this 2016 to 20. Now, post PhD 2021 onwards, I have developed a new arena of research where we have done something called as different types of ML models, benchmarking the different types of ML models based for the accelerated design and discovery of material. Accelerated design of material is basically the shift in the material science research, or otherwise known as AI for science. Okay, AI for science is basically is a very important term where you can just search for AI for science. The why I have entered into this field is also, you know, even the companies like Microsoft, they are opting for AI for science because they need people from chemistry background, they need people from physics background, they need people from PCM, that is biological background also, who want to develop a AI technique for this particular different types of applications, right? So in that, I have focused on the different types of areas where we can see the biopolymers only, right? Biopolymers, we have seen the different types of benchmark, different deep learning models, okay? All these are different terminologies. The large language models are there, okay? These are the maximum of the AI technique as of now, because day by day it is moving on. In 2022, there was only 5 to 10 papers. Now there are 100 papers in this field. So people who are having an idea, please don't delay. Apply some ML model, apply some explainable AI technique, and how we'll see how it can be done in a miniature way within this 1.5 to 2 hours. I will be completing. I cannot be complete the entire whatever I've learned since 4 years. But within this 4 hours, I can give you a nutshell of what all things are there. There's nothing but some seeds I can spread to your land, right? So this is the next one. We can see about the molecular representation. So again, I'm focusing more into this, something called as molecular representation. Molecular representations are basically something called as molecules. We can see the basically the chemical structure, how we are representing the chemical structure in an AA tech, right? So the general type of chemical structure, it cannot be directly given to a system. System should know the language of the chemical structure, right? So for example, we have this H2O, right? H2H and one oxygen is there. CO2, one C and two oxygen. System doesn't know what do you mean by CO2, what do you mean by H2O. But system can understand one type of representation known as simplified molecular entry system, or otherwise known as SMILES. Okay, SMILES or simplified molecular entry system is the fundamental. You can just search. See, I want all. See, I'm just delivering. I want all to involve like whatever I'm asking you to search. If you want to develop, you can see. Just type the SMILES representations. You can see that what are the things are there. So like that, some learning and teaching learning process has to come during this session, right? So simplified molecular entry system is basically the representation, basically the portal for representing the molecular data. See, it does not happen only for the chemical structure, even the biological data, biological structure can be represented in a different form of SMILES, right? So SMILES is basically the base for different types of molecular representation. Then coming on to P SMILES, P otherwise represented as polymer SMILES. So basically, we have the different types of polymers like polyethylene, polypropylene, polyvinyl fluoride, polytetrafluoroethylene. Okay, all these types of polymers can be represented in this form. So this comes under the category of natural language processing, or otherwise known as NLP technique. Okay, so you can just learn the basics of NLP using SMILES or NLP with SMILES. Your friend ChatGPT is there. You can just search what are the different types of NLP techniques used for SMILES. Okay, so In this types of smiles, or otherwise known as P-smiles, and then we can see the third one, that is referencing embedding strings, or otherwise known as selfies. So this is basically a complicated types of smiles where you can see that the benzene ring or some aromatic structures. Okay, chemistry people will be knowing more about it, or it's a general aromatic structure, aliphatic and aromatic, we might have learned in the plus two. That aromatic structure is coming into picture. So that can be done for this. So now you may be thinking how it is connected to the material science. So all the material, there are some chemical structures which we have to represent in the form of a mind. Okay. So you can get the data set. The primary work which you can do from today onwards or from this moment onwards is that you can get the data set of smiles from the Kaggle or some open source, right? Open source benchmarking data sets are available. Take that data set. You can take either as a beginner, as a freshener, or you can take the different types of spine representation for a material system. Or you are focusing on, say, for example, dielectric materials. I worked on dielectric materials, so I'm just talking on dielectric materials. It will be beneficial for people who are from triple E background. So dielectric, different classes of dielectric materials will be there. So take the different classes of dielectric material, get the property distributed, say dielectric loss, dielectric constant, dielectric values, how that is being varied with respect to temperature or with respect to frequency or something which related to your parameter. Take that, you can feed into the system. You can find a new dielectric value for that particular system at a different temperature or an isolated temperature or extreme temperature. This is one of the application of a diversified application for the dielectric material into the right. Now we can see about the quantitative structure property and quantitative structure property. So PSAR models is basically um, we are defining a model for the structure property relation. Okay, so I'll be explaining more about structure property relation because whatever be the structure of a material, we have learned like Austin type, Marston type, okay, effectoid structure based upon the phase diagram. I don't know how far you remember. Using the phase diagram, there is something called the structure property. So based upon the temperature, the phases changes, right? So that change of phases with respect to temperature can be modeled through a quantitative structure property or structure activity model. So that model will be representing that particular material for the change. Yes. So I want now, for past half an hour, I have discussed about this. So I want everyone to have some interactive session right now, like any idea like we have or uh, before moving to the practical session or before moving to the coding. Till now, I have talked, right? So it is an open discussion just for 5 minutes. So then we can move on to the next area. So I want everyone to interact. So at least you can talk something like to this, or you can have some idea about this. This is a brainstorming session also. This should not be like a television, right? I'm telling you, you're hearing, right? You can open your chat GPT or you can see the different type of application. And that is what I told initially itself. Put on to the camera. So if that is difficult, that is fine. No problem at all. But you can have an interaction, at least by audio, like Amrita, I think you can coordinate just for 5 minutes. Then we can move on to the next. Already 45 minutes is over. So I just want, like, people might not have the full understanding, but some ideas, some ways or some discussions we can have.
Yeah, sure.
Yeah.
Participants, I have enabled, you can unmute yourself and ask the doubt, or if you have anything to share, you can do it now.
In the sense,
Stage
doubts
is
don't
open
come
to all.
because you have any ideas or anything which related to your domains or something related to that or something related to what all we have seen now.
Myself, Geeta Pinto.
This time, not even.
Good morning. Actually, I work on cosmetic chemistry.
Okay.
How much I'm interested to develop some biopolymers related containers for the packaging and
Okay.
so how much it is. This conference will be helpful. I don't know. Can you please guide?
Pardon?
whether this conference will be helpful for me
Okay, yes,
in
biopolymers you are doing, right?
yeah.
In biopolymers, what is your plan? What is your objective?
Actually, I'm into cosmetic chemistry.
Okay.
So, two things I'm interested. One is to develop some containers, packaging materials,
Okay. Okay. Okay.
which are uh, from biopolymers.
Yes. Yes.
Another thing is that is personalized cosmetics, development
Okay.
of personalized cosmetics.
Okay. Okay.
So,
Okay.
how do I
Yeah,
connect?
surely.
Because I am
Yeah.
purely from chemistry background, how do
Yeah.
I connect the
Yeah.
AI with the developing the personalized cosmetics? Because I
Sure.
have my
Sure.
own brand of
Understood.
cosmetics.
Understood. Understood. Which
So
type of
how do
biopolymer?
I
Yeah, yeah. You'll be getting beneficial. You'll be getting helpful after this talk for sure, because we are dealing with the biopolymers. How we are different types of biopolymers like hydroxybutyrate, okay, PHP, polyl lactic acid. These are different types of biopolymers where I worked on. So
Mm,
here, what are the property modeling we have done for the biopolymer? Same way you can inculcate that for your domain. That is not a problem. Whether it's a cosmetic
mm,
application or a packaging application. Before that,
mm,
as a chemistry person, you can even see the structure of that biopolymer. Just now I told something about the structure property relation, right? No? So that structure
mm,
property relation, how you can develop that structure to property relation, PSPR and PSAR model, you can take that. So these are the three terminologies I'm just giving you. During this time, you can just search PSPR, PSAR models for the structure property relations of your biopolymer. What is your particular biopolymer? You can find out the papers which is being done for the particular biopolymer. Okay, so that is
mm,
the thing which you can do, and we will be discussing about this how we can inculcate your molecular representation or your biopolymer representation to the system. Okay, I'll be showing one Python code where you can see how your structure can be given. Molecular structure or the chemical structure can be given in the SMILES form to the model, right?
mm, mm.
Good, man. At least you have interacted. Others, 5 to 10 minutes. Then we can move on to the next.
Good morning, Neelesh.
Good morning, sir. Dr. Anil, sir.
Am I audible? No?
Yeah, perfectly
Yeah,
audible. Tell me,
actually,
sir.
I am from Assam.
Okay, tell me, sir.
Yeah, actually, what the AI model will
Yeah,
be more fruitful in this area. So, do we have different types of AI model like
yeah.
ChatGPT or any other?
Okay.
So, what model will be more fruitful in this area? This is my first question. And second question is that actually I am working earlier. I was working earlier in the high temperature development of high temperature materials,
Okay.
right? That is initially I worked in ruthenium aluminide. Then I moved to aluminum alloys. Now I am working in 2000 series and 6000 series alloy. Now,
Okay.
how can I apply this AI model
Sure.
in my area? Because I don't have any idea because I am a old
Yeah.
person and I do not have this access
No
or
problem, sir.
something.
Yeah.
Okay.
Yeah. Yeah. Yeah.
So
Yeah.
now,
Yeah.
thus I want to know how is there any chance or how can I apply this AI model in my
Sure.
area?
Sure. You have thermal graph, thermal stress distribution, thermal property distribution. So, for example, different types of alloys you are telling 6000 series and 2000
Yeah,
series. Okay, sir?
yeah,
So
2000. Yes, yes.
6000 series and 2000 series. What is the behavior of 2000 series and 6000 series for that adverse temperature application? Starting from 0 degree to 100 degree Celsius, say for example, for
Yes.
that particular temperature area, so what is the difference between that behavior of that material towards this temperature? Can you get me the true data for that?
So let me specifically tell you, because
Yeah.
our interest is to develop that material because these materials are naturally aging.
Okay.
Naturally aging.
Yeah,
So
that I understood.
yeah, yeah.
If we want to develop a novel, see something called as novel material or accelerated material design and discovery, as we have seen, this is the agenda or the arena where materials informatics can be applied. This is the see, we are using AI for what? We are finding out AI to find a novel material for accelerated design and discovery, right? So,
Accelerator. Okay.
before moving to the accelerated design and discovery, the experimental data which has been already published, already verified, or are already being promoted for your type of materials, a 2000 series. Suppose it behaves in a different fashion for temperature range of 100 degree to 200 degree. It will be obviously different for 6000 series, correct? As a layman, I'm asking.
Yeah.
So that difference we can get and we can feed into a model, and the new materials, say for example, some other alloy combination can be, say for example, if you're developing a composite of these two, like how we do for the polymers and the materials, if we are developing, we have two composites, the composite A and composite B. And composite A plus B will be a different composite, say C. So C will be having the properties of these two. Same way, if you want a novel material for producing a different types of temperature withstanding capability, so the data has to be given or fed from these 2 point of view. Is it okay, sir? As a fundamental level, I'm telling.
Yes, this is okay. This is okay. Thank you.
Okay, fine. Anyone else? Please. We have 5 more minutes left, then we can start. I want everyone to interact. My humble request. Interaction is very much important than giving a lecture, repeating.
Now, another question. Yeah, just a minute. Just a minute. Another question. That which one that AI model will be more useful in this area?
So that is based upon your data, sir.
With the chat GPT, can I use it?
Yeah. Obviously, you can do. You can use it. You can get the code and everything, but don't trust it fully.
Yeah, that is okay. That is okay.
That is fine.
Yeah.
You can use ChatGPT
Yeah.
or Gemini anything, but that is also a computer. You cannot trust the computer fully. So we have to analyze which model can be applicable for that from your experimental point of view also.
Right.
Some active learning approach should be there, or transfer learning approach should be there. Active learning is nothing but you are finding out an experimental data, and you will be doing a calculation and you'll be finding how much deviation of the experimental data is there. Apart from that, you can find the transfer learning approach also. You can transfer this to some other predefined model which has been already been published or benchmarked. These are the 2 areas where you can validate your. Anyone else? I think only 2 people out of 22. Remaining 20 is there. At least 5 can respond. The remaining 5 can be taken at lesson stage, or again. No one else. At least you can ask anything.
Good morning,
Yeah,
Neelesh
please.
sir.
Good morning, Raviraj sir.
Am I audible?
Yeah, I'm audible.
Yeah.
Please.
My PhD was in developing an biocompatible low reflective coating on surgical instruments, especially made up of 420.
Okay.
So now I'm not introducing any kind of AI during my PhD time, during tours. Now I haven't, that is when I checked for my postdoc. So there is an AI-assisted optimization like predictive modeling for biomedical coating system. That is still remaining some area to be explored.
Yeah. Okay.
So
I can help you.
Yes, that's what I'm asking.
What you can do is actually predictive model you are telling, right? You are told me 2 keywords. One is predictive modeling and AI optimization.
That is biomedical coating system.
Yeah,
that is
whatever.
optimization.
That is your application, but these 2 are important terms. One is predictive model and the second is optimization. The predictive modeling is basically you have a property defined for the particular system. Your experimental data will be there, right? So using that data, you can, since you are not changing the material, the earlier case as other person was telling, you are developing a new material. In this, you are not developing the new material. In that predictive modeling itself, you are trying to optimize your parameters. In that case, what you can do now, you can use this data and you can give the parameters, you can give the constraints using some sort of optimization techniques like genetic algorithm or particle swarm optimization or basic optimization techniques. You can find out an optimal value for it.
Okay.
Then you can compare that with our AI model where you can do many optimization techniques like ADMM is there, alternate in direction multipliers are there. Okay, constraint optimizations are there, using Lagrangian multipliers optimization can be done. Many sort of optimization and the regression models are available for our system.
Okay.
Right? Out of that, the prominent one is the alternating direction method of multipliers, ADMM. Okay, ADMM is a very complicated optimization where you have to define 2 functions. One is a constraint function, one is a objective function. So based upon that constraint function, objective function for a particular material behavior, this can be given as an optimization now.
Okay. So
This is the
because
fundamental idea which I can throw to you. Then you can.
okay, okay, okay,
Tell
okay.
me, sir.
Thank you,
Tell me,
thank
sir.
you.
Anything else?
No, because during my in my work, I used two tools. That is not AI. One is Taguchi, and another one is RSM,
Taguchi and
Design
RSM.
Expert.
Responsive methodology you might have used.
Yes,
In that
yes, yes.
responsive methodology, some box penguin design or CCD design you might have.
I used the box pen then.
Box penguin design. Box penguin design, you might have given some field of parameters, so initial value, final value, some sort of
Yes, yes, exactly.
this thing, and I don't know like exactly. You'll be given some constraints or something like that. Yeah, minimum value, maximum value.
Yes, sir.
Is that so? Yeah, okay. Then you will be giving
Exactly.
some sort of features. Okay. Then you will be taking the responses. And you'll be finding out which is the minimum value, maximum value. You'll be finding optimal solution in the some region.
Okay, sir.
This is what you might have done, approximate.
Yes, yes.
But the
Thank you,
problem
thank you.
is you won't get the exact solution. Why? Because response service will be giving only a surface area where you can get the point.
Yes.
Am I correct or not?
Yes, sir. Yes, sir.
Now,
That's the thing.
for using this type of AI-based optimization techniques, you can get
Hmm.
particular zone or something known as the cluster of the area where your domain can be more focused. Then you can make a comparison, you can easily publish it.
Okay, okay, okay. Thank you, sir. Thank you.
Yeah, very happy that at least 2-3 people. Others, please, some 10 minutes at least. The remaining 1 hour I'll be doing the lecture. By 12 o'clock, we'll go for lunch. At least some 10 minutes. We can have some brainstorming sessions. Otherwise, it will be like how you deliver a class for your students. They'll get bored, you'll also get bored. Anyone else? No one?
Hello. So I
Yeah.
think we can continue the session.
We can
and,
continue. Yeah.
yeah.
I'm opening the next PPT. I think you can see the slide. Slides are visible.
Yes, sir.
Yeah.
Yes, sir.
Fine. Now I'll just move on more deeper into
But
it.
sir,
Yeah.
I think it's better to make it in
Full screen.
presentation mode. Yeah, yeah.
Is it okay?
Yes, sir. It's okay.
So now I'm moving on to the next, like what is how we can apply. See, till now, for the past 1 hour, we have learned about the applications and the various introduction phase. Now I'm moving on to the technical field, okay, or scientific applications of how we can develop this. So molecular representations and structure-based feature vector, basically something called as molecular representation. As I told, you are representing the chemical structure in a different way, right? And structure-based feature vector is basically something called as the different types of structures of the molecules. Either it will be an aliphatic structure or a aromatic structure, okay, a carbon-based nanomaterial structure or based feature vectors, right? So now here we can see the different types of applications where we can see the types of smile strings which can be represented for the various chemical structures. So the fundamental ethene structure is CH2, CH2 as we know. So that we are representing this form. So how we can convert this chemical structure into this? Okay, that can be done using Python language. Okay, any Python language can be done. There is something called as RD kit. Okay, RD kit where you can use this RD kit is a toolbox where you can convert the chemical structure into spine representation. After converting the chemical structure into spine representation, this can be fed directly into the NLP model, right? So after feeding into the NLP model NLP technique or NLP model will distinguish the different types of the smile representations for various applications. This is what the entire AIML framework, which is happening for the chemical structure, right? So we can see the different types of molecules, and we can see the different types of mindset observation for us. Same way, this is what we teach for the people who are from AI for medical engineering, AI for chemical engineering, people who are see accordingly. We can see the different types of observation. Now, I want, as I told you, you might have opened the Google Colab, or those who are familiarized with Python. Please note down this code. Okay, I'll just give you 2 minutes. Please note down this code entirely the same way, either in your Colab or you can any Python, right? So you can just note down within 2 minutes, right? You can just note down. I'll be just back in a minute. You can just note down.
ഹലോ ആ ആ ആ ഓക്കെ ഓക്കെ സാർ ഇത് ഈ സാധനം എങ്ങനെ എങ്ങനെ ടൂള് ഇൻസ്റ്റാൾ ചെയ്യുന്നത് എങ്ങനെയാണ് യാഹഡി ആ ഓക്കെ ആ ആ ഗൂഗിൾ കൊളാബ് ഞാൻ തുറന്നിട്ടുണ്ട് പക്ഷെ യാഹഡി കിറ്റ് എന്ന് പറഞ്ഞ സാധനം ഇവിടെ കാണാനില്ല ആ അതെ എവിടെ ഈ ഫൈൻഡിലാണോ വേണ്ടത് എവിടെ വേണ്ടത് ആ ഫയലില് അതിൽ ന്യൂ നോട്ട്ബുക്കിൻ ഡ്രൈവ് ഒക്കെയാണ് എൻ്റെ വരുന്നത് ഇത് collab.research.google.com എന്നല്ലേ ആ ഗൂഗിൾ കൊളാബിന്റെ ആണ് സെർച്ച് ചെയ്തത് അതിൽ ഫസ്റ്റ് വന്ന ലിങ്ക് ആണ് ആ ഓക്കെ ആ സാർ പോയി വന്നോളൂ
Yes. What you can do is you can just open the collab. I think I'm facing any difficulty. You can just open the Google Colab. Then you can see, I think, wait, I'm also sharing it. 2 minutes. I think you can see this screen. Anyone? Like this, you'll be getting no collab.research.google.com. collab.research.google.com. You can see this. Please respond. New to all of you. Or directly, if you have Python, you can do that, like a Jupyter Notebook or Anaconda or anything like. If you have already installed Python, if you are already working in Python, you can work on that, no problem. This I told you why, because within 1 minute you can get this collab.research.google. You can see that and you can get this window. Then you can see file, okay. File, you can see new notebook in Drive or open notebook, or you can see the new notebook in Drive. You can just click on this. You will be getting a collab file. Okay, in that file, you can just type what you there is, right? And I can do one thing. I'm just copy pasting this into your text or inbox, right? You can see messages. So you can even copy paste that for your ease of comfort. Kunal sir, can you just copy paste this and send this to the WhatsApp or something? I have texted that in this group chat. You can either copy paste that directly into your collab. How many of them have done this or unable to do anything? Please say. Are you doing it or unable to do or not doing or anything? Please respond. Google Colab, you can see directly new file. You can see like this. Okay. File, new notebook. Then directly you can paste that. Okay. Pip install this thing and you can right click this connect button. Right. Then you can see that how it is being done. Connect. So every Google has this allocation for you around like if you having around 1 TB or 2 TB of data, you can feed into it and you can do that. Congrats, sir, or Anil, sir. I only put two people who has responded. Others, Sagar, sir, you can see many people here.
Yeah, I copied
Are you
the
doing it?
file
Yeah,
that you had
yeah,
sent
yeah,
and
yeah, yeah. Please. After
copied
copying,
into.
yeah, we have this another thing also. You can see the different types of representations. So this is a very primary where we can start, right? At a very lower level, we can start this. So that is why I've taken with this. So this types of representations we can find out. I think one person have asked about this biopolymer chemistry person who have interacted with me. Forgot her name, Vidya ma'am. You can see to this. So this type of structures you can give and you can take it as an option for this. Same way for the dielectric materials, for any type of material, you take a chemical structure, you'll be having a chemical structure. Or you take an aluminum alloy, you'll be having an aluminum alloy. There you'll have to use different types of spine representation. So this is the type of area where you can diversify something called as RD kit is there. RD kit. Okay. RD kit is the toolbox in Python where you can import all these descriptors, graphical descriptors, molecular descriptors. Okay. All these you can import from the article, right? So even if you are having difficulty in using Collab, Collab is one of the easiest way, or you can directly use your Jupyter notebook. In Jupyter notebook itself, RDKit will be there as a toolbox. Okay, you can install RDKit as a toolbox. RDKit is a toolbox which is the prerequisite for using the smiles representation.
So can you please repeat? I did not get them.
Ma'am, where are you now? Have you copied down this or you have opened the
Yeah,
Google Colab?
yeah. Open the Google
Google
Colab.
Colab, you can enter a new command, new one, new from the drive. So you can see a new screen, right? Like a Python screen. Have you used Python before? If not, you
Oh
can
no,
direct. Okay,
no, no, no.
okay, fine, no problem. In Google Colab, you can see
Well,
file
file
new,
new notebook in
new
Drive.
notebook in drive. See
Okay.
here? So you can see some window. In that,
Yeah.
you can type this.
What I should type?
That which is I have given in the chat box.
Okay.
I think you have missed before. I have given in the chat box in that pip install RDKit you have to do. You have to install RDKit. That is the toolbox which is there in the Python for giving this molecular representation. Others, we are doing it.
Pip,
Yeah,
pip
yeah.
install.
RDKit. I have given that. I have typed that in the chat box. You can just copy paste that.
Neelesh sir, I am getting a warning that smiles is not defined like that.
No, smiles
After-
only will be getting a warning like that only. Why? Because smiles is not defined because RD kit has to be installed. Pip install RD kit.
Okay.
Anyways, if some errors are coming also, we can solve it out because I'm not there in person. No, so we can solve it out. Before that, we can just know what all things has to be done, and you can the next slide I've taken. You can just give this also as this. Okay, same way you have to type. So smiles, colons, C equal to C1, CC equal to CC1C. So this is just a demonstration example. So I'll be sharing the codes for your reference, and we can also develop this. But before that, you have to install this RD kit. This is the first one which you have to see to it.
Neelesh sir, hello.
Yeah. Tell me, sir.
I have tested these things from chat box.
Pardon.
So next, what
Pardon?
that what you have given in the chat box, I have tested in
Yeah.
the Google Colab. Now, do next
Okay.
step.
Next, you have to connect that. Right side, you can see one connect.
Right side, yes, yeah.
Connect. Then you can see one play button. Play button on the left side. You can just click that. So it will be running.
Play button, yeah,
Yeah.
yes. Play button under that pip
Play
install.
button under that pip install near like left
Yes.
side of the pip install.
Yes.
Okay. So before we clicking the play button, you have to click the connect because this has to be connected to the Google server.
Okay.
Even if errors are coming, please don't worry. Please don't get worried. It's the first time only you're doing it.
Something
So-
syntax error, invalid syntax, something it is coming like this.
Okay, we can solve it out because RD kit some will be there. You can see the slides I've shared. No, sir, the screen is visible. No, you can just counter check what is there in the slide. You can directly copy paste it.
Hello, sir.
Or
The software successfully installed the RD kit.
yes, that is what we want.
Then where I can connect it with.
You can connect right side. You can see one connect. Successfully installed in the green line. It has come right.
Yes, sir.
Then it is fine. Then you can see the next slide, sir. You can see the next slide here. This one, no? Can you see this? Smiles C equal to C1 CC.
Yeah.
CC1,
I can see.
This you can type directly. So you'll be getting this output. So this is basically the smile strings. No? This is the smile string where you can see the output of a chemical structure. This chemical structure which we have already learned. So this is using an AI technique, using an NLP technique, using a representation techniques, we are giving a molecular representation the smiles form. Say for example, this we are given here. Then we are finding out, displaying the image. So this, why I am showing this is to get accustomed to the very fundamental aspect of coding. This is the very basic aspect of coding which we give to the first year or second year BTech engineering graduates. Okay, from that we'll start. Then we'll be using different types of NLP techniques. We'll be using different types of machine learning models for the comparison. Before that, we should understand how this chemistry can be infused to the ML model.
Okay.
Any clarification, others? I think at least one person have caught up correctly. Others, please respond.
Yeah, I could do that. Connect
ma'am.
I did.
Okay.
Then nothing is coming on the screen.
You have to connect.
Yeah,
Left side, you
connected.
have to connect to computer. You can type. You can click that play button.
In my case, successfully install RD kit, which is coming.
Very good, sir. Good. Fantastic.
But
So
the
two people
you
are
have
there. No. I want the response from other people. How many of them have got successfully installed RD kit? How many of them are doing it? How many of them have not got it? Any of them
Where is
have
that?
got? Yeah.
Play button. Sorry.
What happened? Play button you can see. If you're having any errors, just type that instead of copy pasting. Like you might have missed some, even a single code. There is something you'll be having a facing error. And this is the portal where how you can learn, like using Google Colab. Now, if you get an error, paste that error into ChatGPT, you can get this error rectified. Okay. This is the easiest way how you can learn the coding. Those who are not having an exposure with the coding, those who want to enter into it, those who are already being done using Python, for them, no problem. You can directly, how to install the toolbox and things. Those who are not getting accustomed, those who are not there exposure with the Python, this will be a starting point where you can easily install the RDK tutorials. So many toolbox are there in the Python. So even for deep learning toolbox are there, machine learning toolbox are there. So while installing Python, Jupyter Notebook, you can install all the toolboxes. Okay. Then even you can try for MATLAB also. MATLAB is also basically for the mathematical lab operations where you can see, I think, for the different types of machine learning models, that also can be done. But this will be more comfortable for you. That is what I felt. So I just given it. So others, are we doing it or we can move to the next session? I think Raghunath sir, have you got this image or something like that? Output. Anil sir, have you got the output?
No, no, sir. Actually, some things now it is coming
Okay,
satisfied.
we'll sort it out. Okay.
Yeah.
So if not, you can see the different types of structure. Draw the 2D structure. This is an example of how we can draw a 2D structure from this, right? So this is the structure which has been given. You should get the output like this. For getting the output, you are converting this draw molecule to image. You are converting this image to molecule, and then you are showing the image. That's only two-line code is there. So this two-line code is a very fundamental of getting. So before installing this two-line code, you have to install this RD kit or chem import graph descriptors, RD descriptors. If any error has come here, you won't be able to get this. I think very few are getting response. Please do that. It should be practical sessions. So after learning this only, we can go for the next session. Even if you're facing errors, no problem. Get back to me with errors. Or if you're facing the errors, put in ChatGPT, get it. Learn by bugging and debugging. Bug and debug. If you'll be having error, you have to solve that. If you'll be having error, solve that. But that response should be that come from your end. Okay. I think only very few particles. I have to say only 3 participants have responded till now. Others, I think you are just logged in and kept. No problem. But at least those 3 people, you can just see to it. Okay. So after this, we can immediately move to the next NLP technique also, which will be directly helpful for your machine learning model, predictive model, any type of model. Okay. So this is the different types of selfies representations. Okay. Debugging is there, encoding and coding is there. Many things are there in the upcoming slides. So please try to make sure that we can complete by 11:30, 11:45 session. Sure. Raghuraj sir, Anil sir, what is the issue now?
Just I have pasted in the chat box. This
Okay.
is the thing.
Have
I
you
have got it.
installed? Have you installed this RDKit?
Already that is there, na?
No. You have to install that. Successfully installed RDKit has come.
Successfully installed earlier it came. Now it is not
Then
there
that is
because
fine. Only
last.
once is enough. Once is enough.
Now that what is the last 3 lines that is there in that Google column that I have pasted in the chat box. Just look at it. What is actually going on?
1 second.
Yeah.
That is it, sir.
Requirement already satisfied RD kit in something like that. It is coming like this.
Sir, the problem is you haven't connected that. You have to connect that
Connected.
and wait, sir. Connect your to this thing and wait.
Already connected, na? Now that connect button is not have not seen.
It is coming to the server, like some green tick has come on the right side, sir. Connect.
Yes, yes. Connect to hosted runtime or something like that, or connect to Google Cloud runtime, connect to a local runtime, something it is coming like this.
Yeah, local server. Is it coming on the right side, sir?
Not yet. Something RAM disk is there.
Raghuraj sir and Vinita madam, have you completed?
Some error is showing.
No
I'm
problem.
trying to
No problem. We can
fix it.
solve it. Okay. You can either share the screenshot of the error, or you can put that error directly to ChatGPT or some other open source, and you can find the solution for that. I mean, I want
Yeah,
you
directly put in the
to
chat
solve it.
GPT.
Yeah, I want you to
Yeah, I'm
solve it
trying to.
yourself. I can solve it in a second, but I want you to solve it yourself so that it will be helpful for you.
Okay, sure.
Others, Shyam Prasad, no response. Okay, so I think we can do that. Before that, I'll do one thing. I'll share this slides to you so that you can try to do some practical examples based upon this. Apart from that, this another form of representations, selfies to smiles. Different types of smiles representations can be done. So this is something called as encode. Encoding and decoding is something called as fingerprints are there. Fingerprints is basically I think we can listen, then we can move on to the next, because this is something important where you can find out where something called as fingerprints are there. Fingerprints is basically like you're taking out each chemical structure, So the one which is shown in the red and one is shown in the blue. Okay. This type of fingerprints are something called as token, something called as tokenization. Tokenization is a very important aspect where you can give this chemical structures in the form of a tokens, right? Tokens are means small representing the chemical, because this chemical structure we are giving directly to an NLP model, natural language process. So you can, tomorrow's session is also a continuation of this. So today you can do a homework like based upon the NLP, like what is an NLP, fundamentals of NLP, what do you mean by tokenization, what do you mean by fingerprints. So tokenization is basically we are representing each chemical structures into each different tokens, and these tokens accumulate and we are getting a different property or a feature based upon the token, right? So this is something called as encoding and decoding. This slide I'll share. Then some of the material from Taylor's part. So he is the very brainstorm person behind materials informatics. So he has given what is the difference between materials informatics and the machine learning. He has started this in the 2015, the history of this Taylor's parts, and all the materials from Taylor's parts also I'll give you. So you can have an idea about the natural idea about all these different types of, apart from the selfies, we have something called as inchi. Inchi key is another type of representation. So these all are connected to molecular representation, or otherwise known as NLP techniques for materials design. Okay, so NLP text is not only confined to this. NLP is a very vast area where you can give speech, voice recognition, speech recognition, languages. Okay, so now we are giving on to the chemical structure. So this slide I'll be sharing either through webinar, or can share with the participants. So please do that, and you can work on the slides by tomorrow's session. So all these I want you to do it in collab. Okay, I can even do it in collab. It is a purely an error-free command of the code which we are given to the student, because directly if there is an error, you might have lost some statement problem. So either you can copy paste or you can type it. Okay, so you can directly use it and you can find out this thing connected to this. Yeah. So with this we can stop this session as of now. Then you can work on this. By tomorrow's session, we can be focusing more on the molecular representations and mathematics for AI, where we'll be doing the different types of the. Okay, I think Amrita, it's fine. You can share the material now.
Yeah, sure, sir. I can share the material with the participants.
Yeah, you give me and yeah, you can do that with the participants. And participants who are there online, they're available till 12 as your session is there. So this is a practical session. We can have a discussion with here itself. So people who are there, you can also, I mean, I'll be sharing the slides now. You can open the slides and we can work on this. I'll be there in the online. Then we can interact with you during this time, right?
Sure, sir.
Ramath, now itself we can just share, because people can work now itself.
Yeah, sure, sir.
Okay. Just 2 seconds, I'm doing it.
Sir, there is a question in the chat box, I guess. Neelesh, sir? There is a question in the chat box regarding this programming.
I'm on the line. I joined very late. What are we going to learn today? I do not have any knowledge in programming language. It is pretty helpful for me. The first question, sharing slides, that is good for us. And sir, I'm just sharing it within 2 minutes. I think it is shared to now, then you can just transfer to the people. Regarding the second question, I joined very late. Okay, fine. What we are going to learn, actually, the programming language, we are using Python, but we are not directly learning Python. We are using this thing, Google Colab, where you can get a server connected to the Google using your Gmail ID. Okay. Then using the for chemistry people, I'm telling you, we are done with the chemistry. I think you can see the molecular representations. Some code is there, which is also posted in this. You can just copy paste that and you can run it. Okay. Then you have any doubts, you get back to this, right? Available now itself. So directly you can open the Google Colab, as I already discussed, using your Gmail account, and you can copy paste the code and you can find out how the molecular representations can be done. Okay. So I think Amrita have received this thing material.
Yes, sir. I have shared it with the participants in the
have you
WhatsApp
got the
group.
PPT?
Yeah. I shared it with the WhatsApp group also
That is fine.
for the participants.
I think if you have any clarification, we can discuss in the tomorrow session. So I'm just winding up today's session. I think given the fundamental inputs for you to catch up for this today's session, and you can do that. Please do it as a work. And for tomorrow's session, we'll be moving more deeper into it, the mathematics for AI. So this is the thing. So I'm just logging off now. So you can have any clarifications or things, you can post in the WhatsApp group, or we can discuss tomorrow's session. Okay. Thank you, Manath.
Yeah, sure, sir. We can do that tomorrow. They will, if they have any, they can let them do the work today, and if they have any doubt, they can contact you tomorrow during the session.
Thank you all.
So, dear participants, our first session is over now. You can join the session by 2 o'clock for the second session today. I'll share the Google form link now. You can fill the feedback form and you can join for the next session at 2 o'clock. Okay, thank you.